Okay, hello everybody. Today is Wednesday, 10th of June. This is the Metal3 community meeting. As usual, we're going to start with a small introduction round. So if that's the first time you're attending this meeting, feel free to introduce yourself. I'm going to just pause for a while and just take this opportunity. Okay, well, it seems that we don't have anybody new. Let's then just jump directly to the next point. So in the previous meeting, we decided to have a small demo item at the beginning of the agenda. So for today, I have added one that I have myself and want to share with the community that is about the Metal3 data template and the static IP address management in CAPM3 that is coming in V1 Alpha 4. If you also have any demo or something you would want to show, you can add an item there, or otherwise just add your discussion topic in the agenda. So I will then proceed right away with this Metal3 data template and static IP address management demo. So I have an environment ready for this. And are you is it big enough, or should I zoom in maybe?
It looks fine.
Yeah, maybe this is better than. Okay, so basically I have already done the whole deployment because otherwise it takes a bit of time. So we're just going to go through the different kinds of resources that we're adding and created for this. So this is a VM where we just have Metal3 devenv running in the same environment as the CI. So there is already a cluster that was deployed. So just called here test one. So for this, we actually have a couple of Metal3 machines that were deployed. So one that is the control plane and one that is for the workers. The Metal3 machines are actually linked to a bare metal host, as you can see here, node 0 for the control plane and node 1 for the workers. So this is pretty standard. What's changed is mostly in the Metal3 machine, for example, if we have in this namespace, for example, for the controller, we go check what's in the spec. There has been something that was introduced that is this data template field. And the data template points to a new resource that is here named test1 control plane template, and that is a Metal3 data template. The Metal3 data template, so we have two of them. They we are using KCP and machine deployments in this case. So there is one Metal3 data template for each set of Metal3 machines. So there's one for the control plane for KCP and one for the machine deployment for the workers. So in this Metal3 data template, let's open it to show what's in there. So in the spec, we have two main parts, basically, metadata and network data. So those are the way to generate the actual metadata and network data secret that will then be fed to Ironic through the bare metal host. So the metadata part is a set of different maps. The one that we're using here is object names. For example, this one will basically fetch the name of a specific type of object that is used for the Metal3 machine that we're deploying. In that case, you can get the name of the machine that is associated with the Metal3 machine that we're deploying. And we use that to set it as localhost name. Well, okay, there's the two of them actually, with a dash or with an underscore in the metadata that will be provided to Ironic. There, you can do a lot of other things. You can fetch labels, you can fetch annotations, get the IP address of that node. You can get the prefix of the gateway also associated. So all of this will be rendered as in a map where you have like the key, and then the value will be whatever you're trying to render. The second part is this network data. Network data is a definition of the network configuration that will be passed through Ironic. So you have three things in this. The links is the definition of the layer 2 interfaces. So you can have like Ethernet, you can have like VLAN, bond, any like layer 2 device, and you define them in this kind of list. So here we have only Ethernet cards. So we give them an ID, and we need to identify them by MAC address. The thing is, because we're working with a template, we don't really know the actual MAC address that is going to be under that. So there is a utility that called like from host interface that is basically going to fetch the MAC address of the interface called here ENP1S0 from the introspection data of the BMH that is used by the Metal3 machine. So this way we can fetch the MAC address of that interface for a specific node. And then we have that for the two interfaces. Then we have the networks. This is the layer 3 configuration. So you can have IPv4, IPv6, DHCP for IPv4, DHCP for IPv6, SLAAC for IPv6, like it's quite versatile. So in the case of IPv4, you can define the name basically of the network that you're like working with, and then you will get the IP address from an IP pool, and that is like basically the second type of resources that we introduced, like IP pools that are basically defining a subnet from where to get the IP addresses. You can also define the routes. We're going to go back to the IP pool in a bit. So yeah, you can also define the routes if you want for this. And then the third part of it is the services. It's basically just a configuration for the DNS for the lookups. So we have like this two Metal3 data templates that are both linked to from the Metal3 machine. So when reconciling the Metal3 machine, the Metal3 machine controller will actually create something called Metal3 data claim. So a data claim is an object saying, like, representing a query from the Metal3 machine to render the template for itself. So it's named the same way as the Metal3 machine, and just has a very simple spec, a link to the template, basically, which you want to render. And in the status, the Metal3 data template controller will populate it with the actual rendered data. That is the last object related to the Metal3, to the metadata feature. The Metal3 data. The Metal3 data is basically an instance of the Metal3 data template rendering. So you can see that it's actually the name of the Metal3 data template, -0, because this is the first one that was rendered from that template. So in this Metal3 data, we have what has been actually rendered from the template. So you have the link to the claim and the link to the template that are just like referring to the parents, and then you have the metadata section and the network data section. Both of them basically point to the secret that will contain the metadata and the network data for that that will be rendered from the template. And then in the status, you have it set to ready when it actually becomes ready. It's meaning that the template has been rendered and the secrets have been created. So this is how this metadata feature and network data feature currently works, is that when you reconcile a Metal3 machine that points to a Metal3 data template, it will create a Metal3 data claim that will reference this Metal3 data template, and the Metal3 data template controller will reconcile the Metal3 data claim by creating a Metal3 data that contains the actual rendered value from the template. Is there any question at that point before we go to the IPAM part?
Main just a question like hello.
Yeah, we can't really hear you properly. Like it's very faded.
Hello. Is it audible now?
Well, it sounded a bit better in the last seconds, so you can
Okay,
try.
I'll ping you separately for this. Not.
No, it's okay now. You can try.
So like this case, whatever has been defined, it will currently work with the virtual nodes only in the dev environment. Whereas for real nodes, we may not know the for real nodes we may not know the interface names, the productive interface names. So
Yeah, so basically when you're going to be with real nodes, what's going to be changing probably is that during the introspection, your nick list will have like might have different names basically. So when you define your Metal3 data template, you would just put here what you expect to come from the introspection. So you need to know already that your hardware, for example, for the provisioning interface, it would be like ENP6S0, for example.
something, right.
Yeah,
So
so you need
like
to know what kind of like name is expected in that case to be able to get the MAC address of that specific interface.
Okay, so say a condition where you have multiple nodes and they do have different NIC cards present on it. So in that case, like we are not sure like which node will be picked up. So like let's say you define something for a particular host, but is it like always that host will be picked up for, let's say, for master role or for the worker role?
And this feature would actually only work if all your bare metal nodes, like the hardware is
identical.
Exactly, they are identical in the pool that you use for example, for the control plane or for the set of workers. They need to be identical. If they are not identical, you can still split them in different pools, like to have it like. But it becomes a bit more complex. In that case, probably you would be better off not doing it this way. If you have completely heterogeneous hardware.
Yeah. Sure. Thank you.
Okay, good. Then we probably can go to the second part of the demo. That is about the IP pool. So the thing is, when you use this template and you have a network configuration and you need to have static IP addresses because you can't have a DHCP on your network, each of the node needs to get a unique IP address from a pool of IP addresses. So in order to tackle this challenge, we have created a new type of resource called IP pool, and this is a completely different like repository in Metal3. It's the IP address manager. So you can see here that I have created two IP pools. And what does an IP pool look like? It's basically just a definition of what you have available as IP addresses. So you just give the name of the cluster to which this IP pool belong, and then the definition of the different pools that you want to use, like the start IP address that you can use, like for example here, like 100, and the end IP address. You can also give the prefix and the gateway for that network. So it's just a simple definition of like, yeah, this is what you can use basically. The name prefix feature here is to render the naming of the actual IP addresses when they are like generated. So how this will work is that whoever wants an IP address will create an IP claim. And an IP claim is a bit similar to what we had with the, sorry, my bad. What we had in the Metal3 data claim. So it's basically, sorry, let's just go slower. So it's basically a request for an IP address generated for one of the Metal3 data. So you can see that, for example, for the control plane template, we are requesting 2 IP addresses, one from the bare metal v4 pool and one from the provisioning pool. So, and for the workers, it's actually the same. So if we look at what's inside this resource, so you can see here, so the spec is basically a link to the pool from which we want to get an IP address. And in the status, the controller will just put the address object that it generated from that pool. So you can see here that we were given the address object test1 provisioning, like, and the IP will be like 172.22.0.101. So the reason the IP address appears in the name is to prevent collisions when we create the objects. So this means that aside of having like IP pool and IP claim, we also just have IP addresses. So you can see here that there were like 4 IP addresses allocated, 2 from the BMV4, bare metal v4 basically pool, and 2 from the provisioning pool. And in this kind of object, in the spec, we just have like the address that was given and the link to the claim and to the pool that from which this IP address belonged to. So how does this fit in the picture? If you remember, when like when we had the Metal3 data template, I went a bit fast on one of the network. The IPv4 part. So basically we had here like this IP address from IP pool. This is the IP pool that is defined, the provisioning pool and the bare metal v4 pool. And basically by putting this IP address from IP pool, the controller that actually renders the template will create an IP claim for the given IP pool. And once the IP address has been provided for this IP claim, then the template will actually be rendered with that IP address. So now it's time to see like what is actually the output of all of this. So basically we can see from the Metal3 data that, sorry, let's just look at one of the secrets. We can first look into the metadata. So basically we can do just kubectl get secrets. It was created as a secret. Yeah, so yeah, sorry. My oh. No, sorry, my bad. So let's take this one, for example. Yeah. So here we have the metadata. This is base 64 encoded. So if we decode it, you can see the result. The result is a map. And the map contains the 3 keys that we defined, like name, localhost name, and with 2 different ways of writing it. And all of that was set to the name of the machine. So if we do kubectl get machine, sorry, you can see that this is actually here, the control plane. So that's it fetched the name of the machine that was associated to this Metal3 machine. Of course, like you can fetch the name of the bare metal host of the Metal3 machine itself, like whatever you need. So yeah, this is how our metadata looks like. Now, if we look at the network data, for example, from the control plane. So same thing. It's a bit bigger here, but okay, if I decode it, this is what I get. So you can see the definition of the links, and you can see that the MAC addresses were actually replaced with the value that are coming from the BMH. And then in the networks, you can see that the IP address was actually replaced with the IP address that is coming from the pool. And the net mask was also coming from that pool. You can see the same thing for the bare metal v4. That was also like replaced. The IP address was replaced, and you can see also that the gateway was set with what was given from that pool. So this is the configuration that will be passed to Ironic. Sorry, go on.
I was just going to ask you, how do you correlate the MAC addresses to the host names easily? Do you have to look at both secrets and do the correlation yourself, or is there a easier way?
Actually, you already have the link between the Metal3 machine and the BMH. So you just say like, I would want the interface like ENP1S0 of the BMH that will be associated with the Metal3 machine for which I will be rendering that template. So at the rendering time, it will like go back through the chain, you know, get the Metal3 machine and then get the BMH, and from there like look into the interfaces for one that would match the name you gave.
I understand that, but you know,
sorry, I didn't understand the
coming
question.
coming from the other side, debugging. I'm now trying to debug to make sure that I got the right MAC addresses for the right machines. I'm going to have to go look at the machine itself, and then I'm going to have to look at the network that correlates that machine. Correct?
Yes. Then you will need to know like the MAC address for your specific host if you want to verify this.
So there's nowhere in the networks that you could have the host name just pop up in this list, so you either know which host you were looking for when you're looking at the networks.
I'm not sure I understand exactly.
Like right here, what you're showing on the screen, this secret for the network interfaces.
Mm-hmm.
There's no way to have the host name just show up in this list as well?
Well, not that I know, because it's not part of the format of the network configuration.
That's what I was getting at. So I was just looking at from the debug side, how easy would it be? And it looks to me like you're going to have to do both these calls to get that information. That's fine.
Yeah. You would have to like basically, if you just have this secret, you will have to find out which is the owner, which Metal3 machine is the owner of that secret, and then like go back the chain.
So that makes it difficult to debug, but that's okay.
But we can't add. Well, we could actually add more information as another part of the secret, like not as data. Like if we added something more. Yeah.
I was just looking at it from the debug side. You know, how could you make it easier to debug? But that's okay. It's what it is. We can figure it out.
But we could definitely investigate putting more things in the data of the secret, actually. Yeah. So that you would have like network data and maybe like host name. Oh, well, of course it would end up like being base64 encoded, but at least it would be there.
Correct. That's what I was looking at for. That's fine though. I don't know how much debug we'll really have to do, so something to think about down the road.
Yeah, definitely. Thank you for the feedback. And now the last part of the demo, like we're probably like should cut it short because it's already like 25 minutes in, is to actually check how it looks in on the host, basically. So I'm going to go there with the virtual IP address that we have. Oh, sorry, that's from a previous deployment. So you can see here already that the master node has the IP address like 172.22.0.100 and 192.168.111.100. So if we go like check what is the actual status with the cloud init output, we can see that. Oh, sorry about cloud init. And yeah, so this is basically the cloud init part that was given given to the node. It just contains the cloud config, like nothing yet like really interesting for us. But there is another file that is basically in var run in cloud init. Then you have this instance data.json, and that's where what we changed matters, because if we look here, you can see that it's a JSON. It's just provided as a JSON, but it has like this ds.metadata, And in this ds.metadata, you will find basically this like localhost name things and name that we have been given in the metadata secret. In addition, there is this instance ID, Metal3 name and namespace, and UID. This is set automatically by bare metal operator if you don't provide it, because it's just needed to get the whole thing working. So anything that you will put in your Metal3 data template in the metadata part will end up here in this ds.metadata. And anything that you would give in the network data part of the Metal3 data template will end up here in the network_JSON. And you can see again this links and networks structure as we had before. So how is this used? So basically, when we look at the user data, let's go somewhere very good. Okay, I need to find it in the, yeah, here. So you have this kind of references. It's a Jinja 2 template, and you can see that we are actually referring to the metadata part of the user data that I was just showing you like a minute ago. So this is how we use the metadata. So we put in the kubeadm config references like this to some of the fields that we expect to be in the metadata. For the networking, it's a bit different. Cloud-init will automatically take this network_JSON and render it into a net plan. Well, depending on what you're using, in Ubuntu it would be a net plan file. So you can find that under like etc net plan. And there is this file 50-cloud in it. And there you can see that it was actually rendered based on the information that were in network_JSON. So you can see the IP address being set to the proper IP, and then the additional routes here, and then this is applied, resulting in the IP address configuration that we have already seen, that we have here and here. Is there any question?
Nice job, Neil.
Okay, thanks. Then that is the end of the demo, and we should get back then to the rest of the agenda. Doug, next item is yours.
Okay, thanks. So the first of the two items here that I had on the agenda is the reviewer permission changes that we talked about starting a couple of weeks ago. We've had the two proposals up for review for a while now, and we had previously said that the lazy consensus date would be the 12th of June, which is a couple of days from now. So I just wanted to bring it to everybody's attention, make sure everybody had a chance to look it over and comment. And if there aren't any objections by Friday, then I will probably go ahead and start implementing this next week. So I'm assuming that's permission to merge the both policies, and I'll unblock the changes to the owner's files in each repo. A couple of those had, they failed some tests because the reviewer list included people who were not members of the org already. So I'll deal with that by changing the reviewer proposals and inviting those people separately, and we'll get them added to the reviewer list as a separate step. But so were there any questions about the proposal or the timeline or any of the changes that we're talking about making here?
That sounds like a no.
Yeah, okay. So I'm going to assume then if I don't see any comments, negative comments between now and the end of the day, Friday, that it's okay to go ahead and start working on this next week. All right, the next one is just a new design proposal that I wanted to raise some awareness about and get people to look at. This is the idea of adding automatic host discovery to Metal3 so that if an unknown host Pixie boots from our Pixie server, it would register a bare metal host automatically and put that host in a state where we could do some things to it. We wouldn't have management controller credentials, so we couldn't necessarily do power fencing, rebooting in some cases and things like that, but we could potentially provision. I think there's some changes we need to make in Ironic to enable that. But I mostly, this one isn't really looking for an approval. It's looking for folks to take a look and maybe set a date by which we think we could approve this. And maybe a week or two out would be good to give folks a chance to review it.
So what would be the purpose of adding this host into the list if you didn't have management privileges?
Yeah, that's a great question. So there are cases where if you just have a few hosts, it's not that big of a deal to plug them all into the same network, and you just power stuff on and it joins your cluster, and then you can go reconfigure them later. So you could add those credentials later and you could have power control at that point. There's also use cases for just sort of proof of concepts where you're just going to build a cluster. It's going to be there for a little while. It's not going to be a production cluster. You're just going to experiment with stuff. And then maybe you don't care about power management in that case. You just want to get the host provisioned. And we think that with a couple of small changes in Ironic and some work in the Metal3 bare metal operator, we could make that work so that it would boot into the Ironic agent automatically. And then either you could manually provision it using the normal flow of adding a machine, or with the auto provisioning stuff that I don't know if that's made it upstream yet, but we've done some work in the fork of the cluster API provider that will automatically scale a machine set when it sees hosts that match certain criteria. And that will automatically trigger provisioning. And so when that's brought upstream, then you'd basically be able to do that in any cluster that's running Metal3. So basically the idea is you have a cluster and you add a host to the network and you turn it on and it joins as a node, and you don't have to do any extra work.
Fair enough.
Yeah.
I just didn't understand why you would do that without having some kind of management piece.
Yeah. No, the reason we started with the flow that uses the management controller credentials is exactly because of that question. Because,
right.
Yeah. So how long, Mail, do you think we would want to leave this open for review? Obviously, there's going to be code review and details to work out and things like that, but sort of looking for a date where we could take it to the next step, a week or two.
Yeah, there has been already like quite some activity, and then it like has calmed down like on the last couple of days. So probably like I would say a week would be good.
Okay, so maybe by next Friday then, and I'll leave a comment to that effect on the on the review itself.
Yeah, sounds good.
Thanks.
Okay, then let's move to the next topic that is from Jan.
Yes, this is about the PR that I opened yesterday, and it got merged maybe a bit too soon. And this is more the question to Doc and Zane maybe, that if you are strongly against that this annotation should be in BMO, I can of course make a new PR and reverse this. There was quite a lot discussion about where should this be landed in a BMO or CAPM3. Both are okay. I would like to see this in BMO, and I totally get your point as well. But whatever you guys choose, we can go either way. Do you have any comments?
So I think, as I said on the thing, I think the question is this an annotation that we expect every potential consumer of a bare metal host to look at, or is it something that's just for the CAPM3? To my way of thinking, it looks like it's something that's a message to the CAPM3 and therefore should be in that namespace. But if you guys think there is a reason why this should be kind of a generic message to to any potential consumer that you shouldn't touch this host, then I guess that
Yeah,
if you could comment more on that, then that would be what would convince me that it should belong here.
If I may here, so we probably were like seeing it much more like something generic that indeed would not be only like for CAPM3, but basically saying to anything using the BMO under the hood that node should not be used, and anybody could like set the annotation if figuring out that there's a problem with the hardware, and then like so that if, for example, that node was used in a cluster, it's going to be deprovisioned, and CAPM3 is going to stop using it. But we wouldn't want that host to be used by another thing that would like not be aware that it's actually unhealthy and like go and provision it. For example, you have something else built on top of BMO that is not only CAPM3. And in addition to that, like I was also a bit playing with the idea that we could actually count the kind of like unhealthy resources and expose that as a metric from like, so that would be meaning that like actually BMO would act on that annotation.
Maybe this is also something that we should consider when in a future API changes that have been presented earlier. I'm not sure haven't gone that deep into that proposal, but I don't know. These might be. I'm not sure. Are we anyway willing to use any kind of annotations in the future, or how the API will change? But at least at this point, this was my initial idea to have this in place, and sort of a kind of a whoever wants to have this annotation can set it, as Miles said there. This was the original idea.
Yeah, my concern wasn't so much that it was an annotation as that you would normally want the consumer of that API to own that. And if the bare metal operator is not going to respond to that annotation, then it doesn't care what the value is. You know, every controller that uses a bare metal host could define its own way of marking that host as being somehow valid or invalid for itself. You know, we had that same conversation when we did the classification controller work. You know, that was originally being built as a validation tool, but what does valid or invalid mean, right? Maybe it means that it matches something, but not the thing you expected. But if it matches something, then that's a match. That's not valid or invalid. And I think in this case, you know, what's defining healthy or unhealthy? It's not the bare metal operator. It's some outside force. And that thing should own the annotation for that. Now, if we want the bare metal operator to treat a host differently when it is in that state, then that's an API change for the bare metal host. And you're right, we could talk about either an annotation or a change to the spec to somehow make it so that something outside of the bare metal operator could tell the operator this object, the resource behind this API endpoint is not responding healthily in some way. And therefore, you know, you should ignore a request to provision or deprovision it or whatever. You know, we would need to define what those behaviors are. But this is a case where, you know, we're defining a key that something will use to filter resources out of a query. And that's not a thing that the bare metal operator is doing. You know, it's still going to reconcile that host.
Yeah.
So that was my main concern, was not the nature of the change, but really the location and who owns the definition of that thing.
Yeah.
Yeah. So.
Yeah, it's like the bare metal host is the subject of a message between two other systems. So it's
a very
weird
good way to
for
put it.
The namespace for that message to be the bare metal host. But I do kind of see your point about, you know, if it's a thing that's applied manually by a user, then they don't necessarily want to know who the consumer of that is.
Yeah.
And the user doesn't have their own namespace, so it can only really go in the namespace of the bare metal host. I kind of get that. I wonder if we should also have the bare metal host actually do something like deprovision when you do that, because I'm thinking about the proposed API changes, which I need to put in a Google Doc and update. But I think the equivalent in that API would be you would delete the allocation, which would have the effect of preventing anything from any consumers from picking it up, but also it would have the effect of deprovisioning the host if it was provisioned. So maybe that could make more sense. And in that case, the bare metal host would actually be doing something based on that annotation.
Yeah, for sure. But yeah, to make it a little bit shorter now that we have time for other, should we keep this in place, or do you want me to change it, or is this good to go? Because I have another PR hanging and waiting. If this can be in place, we can continue with the other tasks, or what do you guys want me or us to do?
So
What
you're
should we
basically
do?
asking if we should revert. Is that Jan?
Yeah, should we reverse or keep it? Let's just make it simple. Doc.
Yeah, I mean, it's a really tiny thing, but I would rather see it moved to the other repo.
Okay.
And you know, like if it's going to cause a lot of conflict or something, I'm not going to stand and you know, shake my fist or whatever. Like we can move ahead and we can work on this stuff together.
Yeah.
That's not a big deal. But like I want to make sure that as we do these kinds of changes, we think through these sorts of implications. So
Yes, you're absolutely right. And as you said in the discussion, maybe these kind of should have at least some sort of a discussion proposal first. I wasn't sure which way to go, so I pushed this PR in, and it eventually went in.
yeah,
Maybe too
yeah.
hasty, but yeah, sorry about that. But yeah.
No, again, it's not a big deal. I don't want to make too big of a deal over it. I think my preference would be to always have a design review for any API change, not necessarily every code change, but every API change, just because the API is so important to keep right and to think through carefully. And it gives us a chance to do those kinds of things without people getting bogged down in the fact that they already have code written one way and they have to go rewrite it or whatever. Like we can work it out just thinking about it before we start building stuff. And this is such a small thing. Like, I don't know that if you had asked me beforehand, I don't know that I would have said, yeah, we need to do a design review for this, right? But just maybe that's our default is to always do. Yeah.
It would be good if we can keep it in, but whatever you guys want.
Yeah, I agree with what Doug said. I mean, I'm certainly not going to die in a ditch either way. But yeah, API changes, it probably makes sense to have a discussion about those before we start writing code.
That I agree. Yeah.
So maybe a way forward to this one is propose a revert, and we can continue discussing on that PR. Does that sound good to everyone?
Yeah, I mean, maybe we all have deadlines, right? So maybe the thing to do is let Jan move ahead with what he's doing and put in place a plan to move this somewhere else later. And that just becomes part of his implementation plan. So he's not stalled out now. That would be okay too.
Actually, I was thinking that considering our goal, like it might be even actually easier to just directly go with the CapM3 annotation, like defining it in CapM3 so that you do a single PR that adds the annotation and adds the condition in CapM3, and then of course it will be a different namespace, so it wouldn't collide with this one, and then we just revert. Like we can keep discussing on the revert, and if the revert goes through, then good. If it then is rejected, then we can change the annotation that we're using.
Yeah, I like that.
Yeah.
Does that work for you, Jan?
Yeah, I can work on that tomorrow, so not big deal. So
okay,
let's keep this in, and if we want to reverse this, I will. This is quickly reversed because it's so small. Anyways, yeah.
Sounds good.
Thanks, guys.
All right, thank you.
Okay, good. Then the next item. Okay, good. The next item is the ironic authentication proposal. So I have put now like a document out that contains the first draft of the proposal. Please have a look and review and like comment, like change, like whatever. Like I'm going to put the link here. I would like hope to be able to transform that. Transform that into an actual PR, a design proposal PR, like either by end of the week or like by beginning of next week. So if we can have like the discussion here before, that would be great.
I have a question / comment about this. You wrote up a lot of options in there, which is great, but it wasn't super clear on which one we're actually proposing to select. So if we could make that like more explicit, that would be good.
Yeah, the goal. I didn't want to like emphasize so much saying like, yeah, that's what we want to do, because it should be like basically a community decision. But if I can say like what we in EST would want to push for would be definitely the MTLS option. So this one, like having like certificates on both hands of all communications. I can put that in the documentation also, like saying that.
Yeah, I agree with Zane. I believe you should probably have some kind of recommendation. Which one do you think would probably be best?
Okay, sure. Yeah, I can add this.
Yeah, I mean, it's great to have a summary of all the options, but also we need to know which one we're focusing on them, because some of them are clearly like non-starters. Like I think Keystone one is non-starter.
Yeah.
So it's good that we've written it up, but you know, let's discard that one and focus on the ones that we actually think. Which I think the MTLS and the basic auth, it's kind of between those two, isn't it?
Yeah, it's basically between those two.
So yeah, I mean, I don't dislike the MTLS in principle. That was kind of, I know the Ironic folks are working on basic auth support now. And when I heard that, my first reaction was like, why aren't we using MTLS? Because we have to have certs on the Ironic side anyway.
Actually, we discussed this there was the Ironic PTG last week. So we discussed this exact point in the this operator feedback session. So basically, like for supporting the MTLS, because then we would just be running Ironic behind an Apache or whatever, like web server with WSGI. That the web server would be taking care of the certificate. So there would be no changes on the Ironic side. For this, it's just on the CLI actually that. So we were discussing about how we could do a change to the CLI to be able to use certificates when you do like OpenStack, bare metal, node, whatever. Yeah, they like at the moment they're much more focusing on the basic authentication and getting everything like in place, but they were open to the idea of having more.
It was my understanding that the OpenStack client supported client-side certificates for authentication with Keystone, at least. I know we're using NoAuth. So there might be some work to do there, but yeah, kind of surprised that wouldn't work already.
Yeah, it was maybe not investigated deeply enough on my side because I didn't dive in the CLI code for the MTLS.
Okay. So yeah, I mean, the MTLS seems like a valid option. I think, yeah, maybe if we rearrange things so it's like, okay, this is the one we're proposing, and here are the alternatives that we considered. And you know, if someone disagrees, then fine, we can have that discussion. All the information's there, but yeah, at the moment it's a bit too broad to kind of digest.
Okay, great. Thanks for the feedback. Then I'll take the basic authentication and keystone things out of the picture and put it in the alternatives section of the design proposal. Good. Thanks. Let's then move to the next topic. So I wanted to again discuss a bit like the scope of the V1FF4 release that we are discussing for that's mostly for CAPM3. So at the moment we have in the IPAM and the metadata template, so that's already implemented and merged in master. But the other features that we would see going in before releasing V1FF4 would be, well, probably the ironic authentication, because that requires changes on the setup and we are doing anyways changes by including BMO as part of CAPM3. So if we could bundle all this in one step, it would be much easier to achieve a smooth transition from V1FF3 to V1FF4 and not having to add more changes later on. The pivoting work is also pretty in a good shape. Like now it's just about finalizing this move of BMO from its own deployment with Ironic into the CAPM3 deployment, and then making sure that we can still deploy Ironic on its own. Then there was a discussion also a bit about the remediation that we were talking about, like the external remediation for CAPI and how it would play with CAPM3. Because we are basically talking about new CRDs, we are thinking of introducing it in a later minor release because it wouldn't break the backwards compatibility, and we would want to get V1FF4 probably out before this whole remediation work gets out, because it still probably would take like at least a month or two to get this in, considering that it first needs the design proposal in CAPI side to go through, then being implemented, and then the design proposal on Metal3 side with its implementation. So we were like thinking of postponing this. So I just wanted to know if there's any like feedback, any comments or anything related to this scope for V1FF4, like some desired features or something that was not taken into consideration.
I think list looks quite good, and these are anyway quite big things to add into even the one version up. So I would say this looks pretty good at the moment. I don't have anything in mind, at least what we could squeeze in, but yeah, even these ones are, and it's a good idea to have the remediation in the later minor releases. So we get pivoting and IPAM for sure into the first, or are you also planning to have ironic authentication, or should we add that in the later releases as well?
Well, the thing is, ironic authentication is not an API change in itself.
Yeah, exactly.
So it can go like any point. The thing is, we are anyways going to do changes related to BMO and Ironic as part of this pivoting that contains some API changes. So like it is probably much better to bundle the two together so that you do only one operator, like let's say controllers upgrade, instead of having to go through two of them that make substantial changes in the way things are deployed.
Yeah.
So that's why that one is there.
Yeah, good idea.
Okay, then let's move. Wait, yeah, just a note about this remediation in a later minor release that has not yet been discussed with Andrew and Nir. I was hoping that maybe Nir would be on the call, but he's not. So we'll need to take that with them anyways to validate that it's okay with them.
Yeah, we can have a sync meeting later tomorrow, this week or next week maybe. Maybe we should discuss this with them.
Sure. Then next point, Feruz, 4 minutes. Sorry for that.
No problem. That's enough. Yeah, I just added it the proposal here. Sorry, it's been a while that I didn't update the proposal. There were some comments from Zane and Doug, but basically I just updated the document about to push the changes. But I just added it here just to make sure that you guys are okay with the proposal. So the idea is that at the end of the day, anyway, we're doing the retrospection only when the BMH is in ready state. But if it's not, we just basically keep the annotation until the next introspection comes in place. It's a bit similar to Reboot API that is already there. So it's kind of, the implementation will be also similar to that. Yeah. The thing is that, like, I'll just push my changes. Please have a look and review. But it's not a big change because I just need to clarify what will happen in case when annotation is set for the provisioned, for example, or error stated BMH. So yeah.
So Feroz, do you think we can maybe put lazy consensus on this one, or is it still like too much ongoing there for that?
I don't think so. Yeah, I think we can put a lazy consensus for a week if it's okay with others. I will just push it anyway, my changes right now, and then we can wait for a week if there are no any other comments.
Okay, then maybe if it's okay for everybody, then if there's no, like, if all the comments that would come in from now on are like kind of resolved and agreed on by the end of next week, then like that could be the lazy consensus.
Yeah. Okay.
Sounds good.
Okay.
Yeah, I don't think there's any major disagreements on this one. I think we're so yeah, if you want to push some updates, then I can check them over and should be good to go pretty soon.
Yeah, thanks.
Okay, great. Well, the last thing was the issue triage, but considering that we are like pretty much at time already, I don't think we really have much time to go through that. It's already like 59, so maybe we should just stop here for today. Any objections? Someone would really want to do a triage issue?
Not really.
Okay, then let's just stop the meeting here. Like, thank you all for joining, and talk to you in 2 weeks.
Thank you.
Thank you. Bye.
Thanks, everyone.
Thanks, everyone.